Before any of this makes sense, it helps to know how Azure itself is organized, because every policy concept in this course is really just a rule attached somewhere on this structure. At the top sits the tenant root, the single container for an entire organization's Azure presence. Underneath that, management groups let you group multiple subscriptions together, often mirroring how a company is structured: platform, production, non-production, so that settings can apply to a whole cluster of subscriptions at once instead of one at a time. A subscription is a billing and access boundary, the unit Azure actually charges against, and it typically maps to a project, a department, or an environment. Inside a subscription, resource groups are simple containers that hold related resources, a web app and its database, for example, so they can be managed and deleted together. And finally, resources themselves, a virtual machine, a storage account, a network security group, sit inside those resource groups. This tenant root, management group, subscription, resource group, resource chain is what people mean by the resource hierarchy, and it matters here specifically because settings applied higher in this tree cascade down to everything underneath it, a concept that comes up constantly once policy scoping is introduced. Three more building blocks come up constantly and are worth pinning down before moving on. Azure Resource Manager, ARM, is the single API underneath every Azure resource. Every time something gets created, updated, or deleted, whether that request came from the portal, a script, or a pipeline, it ultimately becomes an ARM API call. The Azure CLI, invoked as the AZ command, is simply a command line tool for talking to that same ARM API without opening a browser. AZ group create, AZ policy definition show, and every other AZ command you'll see in this course are just a friendlier way of making the exact same API calls the portal makes. And JSON, JavaScript Object Notation, is the text format almost everything in Azure is described in. Curly braces hold an object made of key:\value pairs, square brackets hold an ordered list of items, and values can be text in quotes, numbers, true or false, or another nested object or list. Every policy definition, every rule, every parameter block you'll see from here on is just JSON structured this way, so being able to read that shape on site, rather than parsing it word by word, makes everything downstream far easier to follow. RBAC, Role-Based Access Control, is Azure's system for controlling who can do what. A role, like owner, contributor, or reader, is a bundle of permissions, and a role assignment grants that role to a specific person, group, or application at a specific scope, one of those same hierarchy levels just covered. So granting someone contributor on a resource group lets them create and manage resources inside that resource group, and nowhere else. RBAC answers who, it says nothing about what the end result has to look like, which is exactly the gap policy exists to fill, and why the two show up together constantly in this course. The other identity concept worth knowing up front is managed identity. Normally, an application or service needs a username and password, or a secret key, to authenticate to Azure. A managed identity removes that entirely by letting Azure itself manage an identity's credentials automatically. It comes in two flavors: system assigned, created automatically and tied to the life cycle of one specific resource, and user assigned, created once as its own standalone resource and attached to multiple things that need to share it. Either way, once a managed identity exists, it can be granted an RBAC role just like a person can, which is exactly how Azure Policy itself is able to go make changes on your behalf later in this course. A handful of specific Azure resource types come up repeatedly in the demos ahead, so a quick plain language definition of each now saves confusion later. A network security group, or NSG, is a basic firewall attached to a subnet or a network interface, a list of allow and deny rules controlling what traffic can flow in and out. A storage account is Azure's general purpose place to store data, blobs, files, tables, queues, and it has settings, like public network access, that control whether the internet at large can reach it. Key Vault is a managed store for secrets, certificates, and encryption keys, so applications don't hard-code passwords into their code. A log analytics workspace is where log and telemetry data gets collected and queried, and it's the backing store behind Azure Monitor. And tags are simple key value labels, like cost center :finance, attached to a resource for organization, cost tracking, or, as this course will show, for a policy rule to check against. None of these are policy-specific concepts, they're ordinary Azure resources, but policy's whole job is enforcing rules about them, so recognizing each by name on site means the demos read as concrete examples instead of unfamiliar jargon. Infrastructure as code just means describing infrastructure in a text file instead of clicking through a portal, so that same file can be reviewed, versioned in Git, and deployed repeatably. ARM templates are Azure's original, verbose JSON format for describing resources declaratively. Bicep is a newer, cleaner language that compiles down to that same ARM template JSON, so it's really just a friendlier way of writing the same thing. Terraform is a third-party, cloud-agnostic tool from HashiCorp that does a similar job but works across Azure, AWS, and other providers using its own configuration language. All three ultimately produce the same result, an ARM API call, they just differ in syntax and in how portable the code is across cloud providers. The other term worth knowing here is Git, a version control system for tracking changes to text files over time, and a pull request, a proposed change to that code that a teammate reviews and approves before it gets merged in. Put together, infrastructure as code plus Git plus a deployment pipeline means a proposed infrastructure change, including a policy change, gets reviewed the same way a proposed code change would, rather than happening silently through a portal click nobody else sees. The last cluster of terms comes up specifically when this course reaches guest configuration and Kubernetes, so it's worth defining now rather than mid-demo. A container packages an application together with everything it needs to run, so it behaves the same regardless of what machine it's running on. Kubernetes is an open-source system for running many containers across a group of machines, handling scheduling, scaling, and recovery automatically. The smallest deployable unit in Kubernetes is called a pod, essentially one or more containers running together. AKS, Azure Kubernetes Service, is Microsoft's managed version of Kubernetes, so you get a working cluster without operating the underlying control plane yourself. An admission controller is a checkpoint inside Kubernetes that inspects every request to create or modify something, a pod, for instance, before it's actually allowed to happen, similar in spirit to how policy inspects an ARM request before a resource gets created. Open Policy Agent, OPA, is a general-purpose engine for writing exactly these kinds of admission rules, using its own rule language called Rego, and Gatekeeper is the specific project that wires OPA into Kubernetes as an admission controller. That's the whole chain. A pod deployment request hits the cluster, Gatekeeper intercepts it, and OPA's Rego rules decide whether it's allowed, which is precisely the mechanism Azure Policy plugs into on AKS. To this Azure Policy deep dive, built for cloud engineers, platform teams, and anyone responsible for keeping an Azure environment compliant at scale. Over the next chapters we'll cover what Azure Policy actually is, how definitions are structured, how rules are written with aliases and logical operators, every effect from audit to deny to DeployIfNotExists, how initiatives group policies together, how assignments and exemptions work, and the tools that help you visualize compliance. Every concept gets a live demo, real JSON, real Azure CLI commands, and a real Azure portal walkthrough, not just slides. Use the chapter list to jump around, or let it play straight through. This deep dive assumes familiarity with core Azure concepts, resource groups, subscriptions, management groups, and RBAC, so the focus stays entirely on how policy layers governance on top of that foundation. Nothing here requires enterprise agreement-only features, everything demoed works on a standard pay-as-you-go subscription with owner or policy contributor plus resource policy contributor rights. Cloud provisioning used to mean clicking through a console or running ad hoc scripts, with no consistent gate on what actually got created. Azure Resource Manager changed that by putting every deployment, portal, CLI, ARM template, Bicep, or Terraform, through the same API. But a single control plane doesn't automatically mean consistent standards, and that's the gap Azure Policy fills. It sits inside that same ARM layer and evaluates every request against your organization's rules, so governance doesn't depend on which tool someone used to deploy a resource. A quick AZ group create against a sandbox subscription, watched live in the activity logs JSON view, makes the point concretely. It's just another ARM API call landing on the exact same endpoint as anything submitted from the portal or a pipeline. Think of ARM as the front door and policy as the guard standing just inside it, checking every single thing that comes through, no matter which key opened the door. Before ARM, the classic deployment model had no single control plane at all, which is part of why governance used to mean spreadsheets and tribal knowledge instead of code-enforced rules. The move to declarative infrastructure, ARM templates, Bicep, Terraform, solved consistency of deployment, but it also meant teams could self-serve infrastructure faster than any human review process could keep up with, which is exactly the gap policy was built to close. At its core, Azure Policy is a service for creating, assigning, and managing policy definitions at scale, and the whole point comes down to three verbs: prevent, detect, and remediate. Prevent means blocking a non-compliant resource before it's ever created. Detect means continuously evaluating what already exists and flagging anything that's drifted out of compliance. Remediate means automatically fixing what's broken instead of just reporting on it. Everything else in this course, definitions, rules, effects, initiatives, is really just the mechanics for achieving one of those three outcomes. It helps to contrast this directly with RBAC. RBAC answers who is allowed to take an action, while policy answers what the result of that action is allowed to look like, completely independent of who performed it. A user with full owner rights can still be denied by policy, and a user with almost no RBAC permissions still benefits from policy's guardrails the moment they try to deploy something. That separation of concerns is what lets governance scale across a large org without turning into a permissions management nightmare. A policy definition is the atomic unit of Azure Policy, a single JSON document describing one rule. Every definition has a display name and description, a metadata block that's purely descriptive, category, version, who created it, and never actually evaluated, and a mode. Mode matters more than it looks. All evaluates every resource type including resource groups and subscriptions. Indexed only evaluates resource types that support tags and location, and resource provider modes like Microsoft.Kubernetes.data are reserved for gatekeeper-based policies running inside X. Get the mode wrong and a policy can silently never fire against the resources you actually care about. The metadata block, while never evaluated, is still worth taking seriously. Category drives which folder a definition shows up under in the portal's browse experience, and version follows semantic versioning so you can track changes to a built-in definition's logic over time. Getting mode wrong is one of the most common real-world mistakes. Assign an indexed mode policy expecting it to catch resource groups, and it simply never fires, with no error, no warning, just silence. Azure ships with well over 200 built-in definitions, maintained and versioned by Microsoft, and a large share of them map directly to Microsoft Defender for cloud recommendations. Opening one in the portal. Say storage accounts should have infrastructure encryption, shows display name. Policy type set to built-in, mode set to indexed, and the raw policy rule underneath. Custom definitions are what you author yourself for anything org specific, naming conventions, allowed regions, mandatory tags, and the same AZ policy definition show command works identically whether you're inspecting a built-in or something you wrote. Built-ins aren't static. Microsoft actively adds and updates them as new resource types and security guidance roll out, which is exactly why pinning to a specific built-in definitions version inside an initiative matters for stability. Custom definitions earn their keep specifically where Microsoft's built-ins can't anticipate your organization's own conventions, a tagging taxonomy, a naming standard tied to your CMDB, or a rule that only makes sense given your internal network topology. Every custom definition needs a definition location, the management group or subscription where it actually lives, and that's different from where it gets assigned later. The rule that trips people up: a definition can only be assigned at or below its own definition location in the hierarchy. So if 3 teams across different subscriptions all need the same custom policy, author it once at a shared management group, root, or platform, rather than duplicating it per subscription. Picture the tree: tenant root, platform, and landing zone management groups, prod and non-prod underneath those, then subscriptions, resource groups, and finally the resources themselves. This rule exists for a real reason, not just portal plumbing. It prevents a team with contributor rights at a low-level subscription from authoring a definition that could theoretically be assigned somewhere they have no business touching, like the tenant root. Getting the hierarchy right up front, generally a shared platform or landing zone management group, saves a painful reauthoring exercise later when 3 different teams have each built their own slightly different version of the same rule. Are what turn one definition into something reusable across very different teams. Take allowed locations. Instead of hard-coding one region, it takes a list of allowed locations array parameter, so the exact same definition can be assigned to one team locked to a single region and another team allowed across 3, without touching the underlying rule at all. A parameter's metadata drives the portal's UI directly, and strong type is the detail worth knowing. Set it to location and the assignment wizard renders an actual region picker instead of a free text box. Set it to a VM SKU type and you get a SKU dropdown, all for free just from that one field. Beyond strong type, allowed values is worth calling out too. It constrains a parameter to a fixed list, rendering as a dropdown in the portal and, more importantly, rejecting any other value at assignment time, which stops a typo in a region name from silently creating a broken assignment. Default value matters just as much for adoption. A well-chosen default means teams can assign a policy with 0 configuration and still get sensible behavior. Every rule boils down to one if, one then. The if side is a condition tree built from all of for n, any of for or, and not for negation, nested as deep as you need. Conditions themselves range from simple, equals, note quals, exists, in, not in, to pattern-based, like and not like, to array-aware, most importantly count, which lets you check things like whether at least one NSG rule allows an inbound port from any address. The then side is just one effect. That's the entire grammar of Azure Policy, and everything more advanced is really just composing these same handful of building blocks more deeply. It's worth demoing count on its own, separate from all of and any of, because it's the condition that trips people up most. Instead of evaluating a single field, it iterates over an array property, like all the rules in an NSG or all the tags on a resource, and lets you assert how many of them match a subcondition. That's the only way to express a check like no NSG rule may allow inbound traffic from any source on port 22 without count. That rule simply isn't expressible. An alias is how a policy rule actually reaches into a resource's real properties. A friendly name the resource provider maps onto a specific JSON path, like Microsoft.storage/storage accounts/supports HTTPS traffic only. Not every property has an alias, only what the resource provider has explicitly exposed, which is exactly why some settings simply can't be policy controlled yet. The portal's rule editor has a live alias search built in, so instead of guessing a property name you can type ahead and see the exact string and which effects it supports. Testing this live, assign a deny rule built on an alias, then try creating a storage account without HTTPS only set, and ARM returns the denial in the terminal in real time, proving the whole chain actually works end to end. It's worth being upfront about the ceiling here. Aliases only expose what the resource provider team chose to expose, so if a property genuinely has no alias, no amount of clever rule writing gets you there. The honest answer is to request it from the resource provider or fall back to guest configuration for anything ARM truly can't see. API version pinning on an alias matters too, since a schema change between versions can silently break a rule written against an older alias path. 4 effects cover most of what you'll reach for day to day. Audit checks whether a resource is compliant after it's already been created, purely a report, nothing gets blocked. AuditIfNotExists checks for the presence of a related configuration. Does this virtual machine actually have a monitoring agent attached? Deny is the hard stop. It prevents a non-compliant resource from being created in the first place. And DeployIfNotExists goes a step further than auditing. It automatically deploys whatever's missing, turning on diagnostic logs for a key vault instead of just flagging that they're off. Everything else, append, modify, disabled, builds on top of these 4 core ideas. It's worth being precise about timing, because it changes how you reason about each effect. Deny and audit both evaluate the incoming request at the moment of creation or update, while AuditIfNotExists and DeployIfNotExists evaluate a separate, related resource after the primary resource already exists, which is why they can lag by however long the compliance scan cycle takes to catch up, unless triggered manually. Beyond the core 4, append and modify quietly rewrite a request before it's evaluated, forcing a tag value or an NSG setting onto a resource without the requester ever seeing it happen. Modify goes further still. It can also remediate resources that already exist, but only with a managed identity attached, which is the single most common thing people forget when a modify or DeployIfNotExists policy silently does nothing. Disabled turns a rule off without deleting the assignment, perfect for a staged rollout, and manual sits off to the side entirely. It's for attestation style controls that can't be auto-evaluated, so someone manually marks the resource compliant or non-compliant instead. And evaluation order actually matters. Append and modify mutate the request first, then deny and audit evaluate that mutated version, and only after the resource exists do AuditIfNotExists and DeployIfNotExists check for what's missing alongside it. Manual deserves a beat of its own because it's genuinely different from every other effect. Nothing about the resource's configuration is inspected automatically. A person marks a specific resource as compliant or non-compliant, with an optional expiration and evidence attachment, which is how policy fits into audits that require human sign-off, physical security controls being the classic example. Real triage starts with finding what's already broken. Filtering the compliance blade by the built-in network security groups on subnets initiative instantly lists every subnet with no NSG attached, and the same query works from the CLI against policy state directly, filtering for non-compliant results tied to that definition. Clicking into any one non-compliant subnet opens a "Why is this non-compliant" panel that shows exactly which field evaluation failed, which is one of the fastest ways to actually learn how a rule's alias logic works in practice, by watching it fail against something real. It's worth pointing out why this check matters so much in practice. A subnet without an NSG isn't necessarily wrong by itself, but it means there's zero network layer filtering at that boundary, so anything landing in that subnet inherits whatever exposure the resource itself has. No safety net underneath it. Exactly the kind of silent gap a point-in-time manual review misses but continuous evaluation catches immediately. Storage accounts with public network access left on are one of the most common findings in any real audit. Assigning the built-in configure storage accounts to disable public network access definition, which uses a modify effect, flags every offending account in the compliance blade immediately. Triggering a remediation task, either through the portal or with AZ policy state trigger scan, actually flips the live setting, not just the compliance report, and checking AZ storage account show afterward confirms public network access has genuinely changed to disabled. That's the proof that modify does real work on real resources, not just paperwork. This finding is worth flagging as one of the highest value checks to enable broadly public network access on a storage account is routinely how sensitive blobs end up indexed by search engines or scraped by automated bots scanning for exactly this misconfiguration, and it's one of the most common root causes behind real-world data exposure incidents. Modify and DeployIfNotExists don't run as you, they run as a service, so Azure Policy needs its own identity with its own RBAC permissions to actually go make the change, whether that's writing a tag, deploying a diagnostic setting, or fixing an existing resource. Without that identity, the policy can evaluate and report all day, but it has no permission to act, and the failure is silent, no error banner, just a resource that stays non-compliant forever. At assignment time you choose system assigned, an identity created and tied to the life cycle of that one assignment, or user assigned, an identity you create once and reuse across multiple assignments, then you grant it a role scope to wherever the remediation needs to happen, log analytics contributor to write diagnostic settings, contributor on a resource group to fix tags. When a new resource lands and trips a DeployIfNotExists rule, or a remediation task runs against something already non-compliant, the engine authenticates as that identity and performs the deployment under its permissions, not the original requesters. Check the identity's role assignment right after creating it. That one missing step is behind almost every "why isn't this remediating" support ticket. One more nuance worth calling out: the identity's role assignment scope has to cover everywhere the fix might need to write, not just the resource being evaluated. A DeployIfNotExists policy writing a diagnostic setting into a log analytics workspace needs writes on that workspace too, not just on the resource being monitored. A scope people forget when they grant the identity a role only at the assignment's own scope. 3 assignments built on the exact same underlying rule logic, but 3 different effects make the contrast concrete: 1 set to append, 1 to audit, 1 to deny. Attempting a resource creation that violates the append policy shows the tag getting silently added, and AZ resource show afterward proves the tag exists even though no one ever set it by hand. Then a full DeployIfNotExists walkthrough using the built-in policy that deploys diagnostic settings for Key Vault to a log analytics workspace. The assignment wizard's remediation tab auto creates a managed identity and asks which role to grant it, log analytics contributor in this case. After assigning, policy to remediation either waits for the natural evaluation cycle or gets triggered manually, and a remediation task appears with its own deployment history, proof that DeployIfNotExists doesn't just flag a gap, it closes it. Worth narrating explicitly during the audit portion: the resource creation succeeds exactly as requested, nothing about the API response changes, and the only signal a requester gets is a compliance flag that shows up later in the portal or via API, never in their own deployment output. Precisely why audit is the safe default for testing a new rule's real-world blast radius before ever touching deny. Some checks can't be answered from ARM properties alone, they need to look inside the resource. Guest configuration runs an agent inside a VM to audit OS level settings, password policy, whether Defender is enabled, and it typically depends on an extension that's often installed by another DeployIfNotExists policy, a nice example of policy deploying the thing that lets other policy work. On AX, Azure Policy is built on Gatekeeper, an open policy agent admission controller, so a constraint gets wrapped in the same definition format and assigned the same way, but underneath it's evaluating rego against every pod admission request. Turning it on is one CLI flag, enabling the Azure Policy add-on on the cluster, and once a baseline initiative is assigned to the cluster's resource group, a privileged pod deployment gets rejected right at the Quebec apply. Worth being clear about the performance cost of guest configuration, because it depends on an in-guest agent polling on its own schedule, typically every 15 minutes by default. It's inherently slower to reflect a change than an ARM-level policy, so it's the right tool for OS-level settings that genuinely can't be seen any other way, not a substitute for ARM-level checks wherever those are available. For AX, Gatekeeper enforces at admission time by default, meaning a violating pod is rejected before it's ever scheduled. An initiative bundles multiple definitions into one assignable unit, which matters for two reasons: cleaner compliance reporting, one rolled up percentage for an entire framework instead of tracking 40 separate assignments, and initiative level parameters that fan out to every underlying policy that needs them at once. Building a custom initiative in the portal means adding several existing definitions, mapping one shared parameter like allowed locations down into each one, and assigning the whole bundle in a single operation. Built-in initiatives worth knowing include the Microsoft Cloud Security Benchmark and the SIS Microsoft Azure Foundations Benchmark, both a fast way to get broad coverage without authoring anything yourself. Group names deserves a specific mention because it's what turns a flat list of 40 policies into something a compliance reviewer can actually navigate. Tagging each definition inside the initiative with a category like network security or data protection means the compliance blade renders those as expandable sections instead of one undifferentiated wall of results. An assignment binds a definition or initiative to a scope, with its own parameter values, and scope inherits downward. Assigning at a management group cascades to every subscription and resource beneath it. Two controls matter for rolling things out safely. Enforcement mode set to do not enforce evaluates and reports compliance without actually blocking or deploying anything, ideal for seeing a deny policy's real blast radius before switching it on for real. Not scopes excludes specific paths from an otherwise broad assignment, deny public IPS across the whole subscription, but not scope the sandbox resource group so testing isn't blocked. Deploying a non-compliant resource inside the excluded scope succeeds, the exact same deployment outside it gets denied. Worth being explicit that scope and definition location are separate concerns beginners often conflate. A definition authored at the tenant root can still be assigned narrowly at a single resource group. The location only sets the ceiling on how high an assignment can reach, not a floor. Not scopes supports wildcards too, so excluding every sandbox prefixed resource group across a subscription is one line, not one exclusion per sandbox. Azure Blueprints historically bundled policy assignments, RBAC, and ARM templates into one versioned artifact for landing zone deployments, though Microsoft has been steering customers toward template specs, deployment stacks, and landing zone accelerators instead. Worth double-checking current guidance before leaning on blueprints for anything new. The approach that's held up is policy as code, definitions, initiatives, and assignments authored as Bicep or Terraform, stored in Git, reviewed through a pull request, and deployed via pipeline, the same rigor applied to application code. A short Bicep file deploying a definition and its assignment together, run through AZ deployment sub-create, produces the exact same result as clicking through the portal, except now it's version controlled and repeatable. For teams standardizing on Terraform, the exact resources map cleanly onto the same JSON shape used everywhere else. Azure policy definition, Azure policy set definition for initiatives, and Azure policy assignment, so nothing about the rule logic itself changes, only how it's packaged and deployed. The real win of policy as code isn't just repeatability, it's that a proposed policy change goes through the same review gate as a proposed application change. Exemption is not the same thing as a not scope. Not scope is set by the policy owner at assignment time, an exemption is granted per resource afterward, usually by a different person requesting a waiver, and it requires the resource policy contributor role or higher. There are two categories: waiver for an accepted risk with no compensating control, and mitigated for a risk that's covered some other way. The detail that matters most: always set an expiration date. Creating one with a 5-minute expiration for a demo, watching the resource flip to exempt immediately, and then watching it automatically revert to non-compliant once that expiration passes is the clearest way to prove exemptions are meant to be temporary, never a permanent silent gap. Worth demoing resource selectors briefly too, since they're an underused feature. Instead of exempting an entire resource from every policy in an initiative, a resource selector lets you exempt it from just the specific policies inside that initiative that don't apply, say, exempting a legacy VM from an OS patching policy while still holding it to every other control in the same baseline initiative. Cloud Adoption Framework is the place to see how policy fits into a broader governance model, landing zones, guardrails, the whole picture, rather than being read in isolation. Beyond that, two tools round out day-to-day work with Azure Policy beyond the compliance blade itself. Azure Advertiser is a community catalog for browsing every built-in and custom policy definition, initiative, and alias across a tenant, and for tracking what's new or changed in Microsoft's built-ins, genuinely useful when the portal's own filtering feels slow. Azure Workbooks, the same engine behind Azure Monitor dashboards, adds trend over time compliance percentages instead of a single point-in-time snapshot, cross-initiative rollups on one canvas, and shareable, exportable views built for a security review or an audit, not a live screen share of the portal. Cloning the built-in Azure Policy Compliance Workbook template and adding one custom filtered query takes minutes and gives a team something durable to actually look at. Worth mentioning Microsoft Defender for Cloud's own recommendations page 2, since it surfaces many of the same non-compliance findings from a security posture angle rather than a governance angle, and cross-referencing the two occasionally surfaces gaps where a Defender recommendation exists but no corresponding policy assignment is actually enforcing it yet. Word rule gets reused across 4 very different Azure and security tools, and conflating them is a common source of confusion. An Azure policy rule is an if/then condition evaluated by Azure Resource Manager itself, against the configuration of a resource, at or after the moment it's created, and it can prevent, audit, or remediate. Microsoft Defender for Cloud doesn't really give you a rule language to author at all for most of its coverage. Its recommendations are largely backed by Azure policy definitions under the hood, rolled up into a secure score, while its threat alerts come from Microsoft's own analytics and threat intelligence running behind the scenes, not something you write yourself. Splunk is a general-purpose SIEM. A correlation search is a saved SPL query run on a schedule against whatever logs you've indexed, cloud, on-prem, firewall, anything, and it fires a notable event or alert when the query returns results. Microsoft Sentinel is Microsoft's cloud-native SIEM. An analytics rule is a saved KQL query run against data in a log analytics workspace, on a schedule, near real-time, or via Fusion's ML correlation, and instead of just an alert it creates an incident with entities attached, ready to feed an automation playbook. The throughline, policy governs what a resource is allowed to look like. Defender, Splunk, and Sentinel all reason about logs and behavior after the fact, they just differ in how open the rule language is and whether the output is a score, an alert, or a full incident. One concrete requirement, catching a storage account that's publicly accessible, and write it 4 different ways to see exactly where each tool sits in the pipeline. In Azure Policy, it's a deny or audit rule checking the public network access field directly against the resource, blocking the create call itself before a public storage account can ever exist. In Defender for Cloud, the same check shows up as a built-in recommendation. Storage accounts should restrict network access, which is a policy definition under the covers feeding your secure score, and separately, if the account is already public, Defender's threat protection can raise an alert like anomalous access to a storage account when it sees unusual access patterns against it, using Microsoft's own detection logic, not a rule you wrote. In Splunk, once those storage access logs are flowing into an index, a correlation search counts anonymous requests per account over a time window and fires a notable event when that count crosses a threshold you set. In Sentinel, the equivalent is a KQL analytics rule against the storage bloblogs table, summarizing anonymous request counts by account and caller IP, scheduled to run every few minutes, mapped to a MITRE ATT and CK technique, and producing an incident with the storage account and IP as entities ready for an automation playbook. Notice the shape. Policy stops the bad state from ever existing. Defender scores the posture and watches for anomalies with its own logic. Splunk and Sentinel both let you write the exact detection logic yourself. the real difference between them being SPL versus KQL and a notable event versus a MITRE mapped incident with entities attached. That's the full arc, what Azure Policy actually does, how definitions are structured and scoped, how rules are built from aliases and logical operators, every effect from audit through DeployIfNotExists, how initiatives and assignments scale governance across a whole hierarchy, and how exemptions handle the exceptions safely. A short list of habits separates a policy rollout that goes well from one that causes an outage. Start every new custom policy in audit or do not enforce mode, assign at the highest sensible scope and use not scopes for the exceptions, group related rules into initiatives once you have more than a handful, treat every exemption as temporary with a real expiration date, and move definitions into Git and a pipeline the moment they stop being a one-off experiment. The fastest way to make any of this stick is the same as anything technical: build a sandbox, break a few resources on purpose, and watch policy catch them. One closing thought worth leaving the audience with: none of this replaces good communication with the teams whose resources get evaluated. A deny policy that lands with zero warning reads as an outage to the team hitting it, even when it's working exactly as designed. So pairing every new enforced policy with a heads up in the right channel is as much a part of a healthy rollout as the do not enforce testing phase itself.